Hi everyone, welcome to the Vector Algebra Part 2 of the Basic Mathematics for Physics series. In this video, we will be covering multiplication of vectors. If you have not yet watched the previous video, Vector Algebra Part 1, please do watch it before proceeding with this video. I have put the link in the description also. And if you have not yet subscribed to Easy Exam Academy channel, please do subscribe and click on the bell icon for more updates. Let's get started. Multiplication of vectors is classified into scalar multiplication and vector multiplication. In the vector multiplication, we will be classifying into dot product as well as the cross product. In normal mathematics, if I consider the values 3 multiplied by 2, that is 6. If I write 3.2, that is also 6 only. If I consider 3 brackets of 2, that is also written as 6 only. But in vectors, 3 cross 2 is very different. That is called cross product. A dot B, that is very different. That is called as dot product. And scalar multiplication, that is lambda into A, that is completely a different concept. In general mathematics, in arithmetic, rational numbers or real numbers or whatever we call it, the multiplication is defined to be repeated addition, and similarly division is considered to be repeated subtraction. But in vector algebra, we will be defining multiplication as scalar multiplication and vector multiplication. Scalar multiplication is nothing but just increasing the magnitude of the vector. For example, if I have a vector a bar is equal to 2i cap plus 3j cap plus 4k cap, and if I am writing it as 5a bar, that means I am multiplying 5 with all the values, which becomes equal to 10i cap plus 15j cap plus 20k cap. So this, what it does is, if a vector is like this, it multiplies the vector 5 times in magnitude. That means the new vector becomes like this, 5a bar. This is called as scalar multiplication. There is no symbols is used to denote this multiplication. Now let us understand the dot product of two vectors. Dot product of two vectors is defined as a bar dot b bar is equal to modulus of a bar into modulus of b bar into cos theta, where theta is the angle between the two vectors. This basically denotes a concept called as projection. Projection means if I take Taj Mahal and view from the top, it looks as if there are 5 circles like this and a lake like this, right? This is the top view projection of Taj Mahal. Similarly, in engineering and in physics, there are some concepts called as projection. We can find the projection of a vector over another vector by using the concept of dot product. So basically, when two vectors are perpendicular, always remember, when theta is equal to 90 degree, cos 90 degree becomes equal to 0. So a bar dot b bar becomes 0. So when two vectors are perpendicular to each other, then the dot product is 0. So dot product is a test to find whether two vectors are perpendicular or not. Similarly, we can find the angle between the two vectors by using the dot products, which I will be explaining it later. Now, let us find out what is I cap dot j cap. I cap is x-axis, j cap is y-axis. X-axis and y-axis both are perpendicular to each other. Immediately, I can write mod I cap into mod j cap and cos of 90 degree, which becomes 1, 1 and 0. So this becomes 0. Similarly, I can tell j cap cross k cap is equal to 0. K cap cross I cap is also equal to 0. What happens to I cap dot I cap? That becomes mod I cap into cos of angle between I and I is 0. So cos 0, which is equal to 1, 1, 1, that is 1. Similarly, j dot j is also equal to 1. K dot k is also equal to 1. So this is what we have defined what is the meaning of dot product. Let us consider two vectors. A bar is equal to 3i cap plus 2j cap plus k cap, and b bar can be written as minus 2i cap plus 3j cap plus 4k cap. If I want to do the dot product a bar dot b bar, let me take 3i cap plus 2j cap plus k cap dot product of minus 2i cap plus 3j cap plus 4k cap. Here I will be getting, if I multiply it, minus 6i cap dot I cap plus 9i cap dot j cap plus and so on so. This is 6 j cap dot j cap plus and so on so plus 4 k cap dot k cap. You can clearly see that all the other terms except the 3 into minus 2, 2 into 3 and 1 into 4 gets cancelled out because they are perpendicular. I dot j and j dot k, they are all perpendicular. We know the dot product will be equal to 0. The last remaining will be the three things only. So the answer is minus 6 plus this is 6 plus 4 and the answer comes out to be 4. So the a bar dot b bar answer is equal to 4. So always remember, when we are multiplying two vectors, you will be getting a scalar value when you are doing the dot product. That is why this is also called as scalar product. Remember, scalar multiplication is different, scalar product is different. So dot product will always result in a number. Two vectors are merging together to form a number. Now let us come to the cross product. A bar cross b bar will give another vector c bar such that c bar is perpendicular to a bar as well as c bar is perpendicular to b bar. If you think of a vector that is perpendicular to both a bar and both b bar, it will always be in the out of the plane that a bar and b bar are residing. I will explain this. Let us take two vectors here in the plane. If I want to find a vector which is perpendicular to both a bar as well as b bar, if I draw a line like this is perpendicular to a bar but it is not perpendicular to b bar. Similarly, if I draw a line like this is perpendicular to b bar but it is not perpendicular to a bar. The only possible way in which the vector is perpendicular to both a and b is it should be like this, cutting through the plane of the paper of A and B. This is C bar. That means if I take the x-axis and y-axis, the cross product of x-axis and y-axis should give you the z-axis. So it is out of the plane of the paper in which the two vectors are lying. Keep that in mind. So many students confuse A bar cross product B bar is equal to mod A mod B sin theta, which is not the correct procedure. Always remember, A bar cross B bar will give another vector such that the vector is perpendicular to both A bar as well as B bar. Remember that in your mind. So we know that what is I cross J, that will become equal to K cap. How to find the directions of the vector? It is by using some method called as right hand thumb rule. But I will tell you a very easy method to remember the directions of the vector. That is called IJK circle method. If I take I, this is J and this is K. You mark the arrow marks like this. This is IJK circle. From the circle, I cross J will take you to K. J cross K will take you to I. K cross I will take you to J. If I move in the opposite direction like this, let us say J cross I, you need to put a negative sign. So it becomes minus K. If I write it as K cross J, then it goes to minus I. Similarly, I cross K will be equal to minus J. So always remember this circle, IJK circle, it is always written in this format. Now the question arises, how do we find the cross product of these two given vectors? So before moving to that, let us define another one. Modulus of A cross B is equal to mod A mod B into sin theta. So when theta is equal to 0 degree, then sin theta is equal to 0, which means A cross B is equal to 0. So when two vectors are parallel, then we can tell that their cross products will be 0. So the condition for parallel vectors is verified by the taking cross product of the two vectors. When the cross product of two vectors is becoming 0, then the two vectors are parallel. As in the case of perpendicularity, when you dot product the two vectors, when answer becomes 0, then the two vectors are perpendicular. If I write what is I cross I, that becomes modulus of I and the angle between I and I is 0 degree. So the answer is 0. So I cross I will be 0, J cross J will be 0, K cross K will also be equal to 0. So when I am trying to do the cross product of these two vectors, 3 into 2 I cross I will become 0. So the total out of the 3 terms will become 0 and 6 terms will be remaining. So this becomes little bit complicated in order to solve, right? So for this, there is a easy method called as the determinant method, which you need to follow like that. Let us see what is the determinant method. So write down the vectors like this: I, J, K, 3, 2, 1, the coefficients -2, 3 and 4, and put plus, minus and plus here. So for the sake of simplicity, I am explaining it to you in detail. So first you cancel out this row and this column and cross multiply as shown in the figure and put the I here. 4 into 2 minus 3 into 1. Next, cancel out this second one, and since minus is here, cross multiply here and write down minus j into 4 into 3 minus 2 into 1. Then at last row you cancel it out and write down like this. So plus, since plus is there, plus minus plus k into 3 into 3 minus of minus 2 into 2. So the final answer comes out to be I into 8 minus 3 minus j into 12 plus 2 plus k into 9 plus 4. So the final cross product answer is 5 I cap minus 14 j cap plus 13 k cap. This is the final cross product answer. So hope you have understood how to do the dot product and cross product of the vectors. So if you have any doubts and clarification required, please feel free to post in the comment section. I'll be posting a video regarding that. Thank you for watching.